Our next topic is going to be global warming. Now, we're in fact going to change the name slightly as we get into the science behind the idea of global warming. But I picked out this first slide just to make sure we're all aware of the sensationalism that comes with global warming. It is an extremely hot topic in the media and in the political theatre, with both sides of the issue making extremely wild, outrageous and sensational claims. What we're going to try and do is cut away at the fluff that's surrounding the global warming debate and try and look at some of the science that's there and really understand that some of this we just don't know yet and some of it may be unknowable. One thing that is knowable is that temperatures on the planet are increasing. So we know that the temperature on the planet is increasing. And even though this slide is filled with humour, there is really no debate that the temperature is actually increasing around the globe. The debate comes as to why that temperature is increasing and if the temperature change is a long-term effect or a short-term effect. If it's only a short-term couple of years and then we go back to normal, there's no need to change our behaviors or modify our industries. If it's a long-term change, then maybe we need to change our industries and modify our behaviors to mitigate that change in temperature. Or maybe we just decide that we can live with the change in temperature on the planet. Remember that the bottom zone of the atmosphere is the troposphere. And it's in this troposphere that you and I live, walk around and do all of our activities. So it's in this tropospheric zone that we're looking at measuring the temperature and seeing what's happening with global warming. So here's the first thing you've got to understand. The greenhouse effect and the warming of the Earth are two separate issues. The greenhouse effect is the scientific model that explains how heat is trapped on our planet. Global warming is the term the press use to explain that the planet is getting hotter and hotter. So we're going to separate the two. We're going to do just the greenhouse effect to start with, and then once we understand the greenhouse effect, then we'll move over and see how that influences the warming of the planet. So this first thing we're doing is we're just doing the greenhouse effect. Now we know that our atmosphere is made up of a collection of different gases. And when we did solar power, passive solar energy, we talked about how light can pass through the glass of a car, go inside the car, be changed into thermal radiation, infrared radiation, and then be trapped inside that car. So the inside of your car, sitting in the parking lot in the middle of summer, gets hotter and hotter and hotter, and the inside of the car will end up being hotter than the outside. Well, our atmosphere functions in exactly the same way. It's made up of a collection of different gases. When sunlight and solar radiation passes into the planet, that solar radiation can often pass through the atmosphere. But when that solar radiation hits the Earth, it then gets converted in form, and it's changed into more of a thermal energy. It's changed into an infrared energy. Those infrared rays cannot pass back through the atmosphere, so they're trapped inside the atmosphere in the troposphere where we're living. So just like the heat was being trapped inside the car, the heat is being trapped inside the atmosphere, inside the troposphere, right where we're living. So our zone is warmed by the greenhouse effect. This is not a negative effect. There is nothing negative about the greenhouse effect. It is fabulous for the planet. What we need to do is look at another body that's about the same distance as we are from the sun to see what a positive effect the greenhouse gases have. So let's just compare Earth to the Moon. The Earth and Moon are about the same distance from the sun. We get about the same amount of solar radiation. And if you're on the Earth, sitting here in Georgia, and it's the middle of the day, like it is right now while I'm doing this lecture, outside today, it happens to be 92 degrees. Now there's no doubt 92 degrees is really, really hot, but you can survive in 92 degrees weather. Now, the reason that it's not hotter than that is because some of the solar radiation is reflected by our atmosphere. Not all of it makes it down to the ground where we're living. Now, at night, the temperature tonight will probably be round about 72 to 74 degrees. And again, that's definitely livable. You can be out there in that. It's not too hot, it's not too cold. The reason that it doesn't get freezing cold at night when we have no solar energy added to the planet is because the heat is trapped in by our atmosphere. Our greenhouse gases trap the heat on the planet, so all night long heat is here, it's trapped where we're living, and it allows us to survive the night time. So in the day, the greenhouse gases limit the amount of energy passing into the Earth, and at night the greenhouse gases trap energy, keeping the Earth warm. Now let's go over to the Moon with an extremely thin atmosphere and see what's happening there. About the same distance. During the day, in the sunshine, the Moon's about plus 200 degrees. So it's about 200 degrees, way too hot for life as we know it to exist. At night, on the shady side, where there is no sunlight, it's about minus 200 degrees. So why is it so different to Earth? That's because without that atmosphere, without those greenhouse gases, during the day it's receiving much higher strength solar radiation. So that solar radiation is just really heating up that Moon surface. And then of course at night, without that atmospheric shield to blanket the body and trap in the heat, all of the heat gets radiated out into the universe extremely quickly. So temperatures drop very, very fast, and within a very short amount of time they're down to a frigid minus 200 degrees. So on the Moon we just don't have the conditions to support life. The greenhouse effect is a positive thing. It is allowing the mitigation of the temperature, cooling of the temperature during the day, warming of the temperature during the night, so that we don't get big swings between boiling hot days, frigid evenings, boiling hot days, frigid evenings, and allowing us to have a carbon and water-based life form that we find all around the planet. So the greenhouse effect has a huge benefit for the Earth. And without the greenhouse effect, life just would not exist as we know it. You cannot view the greenhouse effect as being a negative. Changes in the types of greenhouse gases that are in our atmosphere, or changes in the amount of those greenhouse gases in the atmosphere, would obviously change how strong the greenhouse effect was. If we added more greenhouse gases, and greenhouse gases are just those gases that cause the greenhouse effect, to the atmosphere, if we added more of them, then it would trap more heat each night, trap more heat during the day, and the planet would warm up. If we could reduce the number of greenhouse gases, then we would see the opposite effect. The planet would get cooler. Now also, if we change the mix of greenhouse gases, if we add certain gases and remove other gases, you can have an effect on how efficient the greenhouse effect is working. So if we look at climate records, and we can do that by taking ice cores from Antarctica and seeing what the gas mixtures were like inside the air during the past thousands of years, we can see that greenhouse gas concentrations tended to show a very close correlation with the global temperatures of the planet. So we're seeing this: if greenhouse gas composition changes, then global temperatures change. So what are the greenhouse gases? The most abundant greenhouse gas, the one that's found in the largest amount, is carbon dioxide. So there's large amounts of carbon dioxide in the atmosphere. This carbon dioxide traps heat, producing our greenhouse effect. Second greenhouse gas is methane. Now, methane is a natural byproduct of the decomposition of organic matter. So as plants decay, as animals decay, it's often broken down and released as methane. So methane is naturally released from the planet, passes into the atmosphere, and becomes a greenhouse gas. if we add more methane to the atmosphere, then it would cause the planet to warm. Third greenhouse gas, nitrous oxides. Now, in our previous lecture we talked about how burning fossil fuels, particularly in automobiles, produces our NOx's. And if our NOx's pass out into the atmosphere, they will act as a greenhouse gas and also lead to the warming of the planet. It's not only that though, we also add large amounts of nitrogen to our farm fields, and as agriculture uses nitrogen fertilizers, there is bacterial decay of those fertilizers that release nitrogen into the atmosphere as well, and this agricultural formed nitrogen can lead to greenhouse effects. And the last one on our list, chlorofluorocarbons, CFCs. CFCs used to be the refrigerant that was in air conditioning systems and refrigerators. Now CFCs are now banned in the United States because not only do they have an effect on the greenhouse gas, they also destroyed ozone in our ozone oxygen layer. And you've probably read in your book already how the ozone oxygen layer protects us from ultraviolet light. Well, the way that we managed to solve this destruction of the ozone layer is we just remove the use of chlorofluorocarbons. So out of the ones on this page, the ones that are most interest to us are the nitrous oxides, the methane, and the carbon dioxide, because these ones are still being produced in the United States today. A gas that's not listed on that previous slide, but has probably the most important impact on the temperature of the planet, is shown in this slide. Now, it's not actually listed in the slide, but when you look at the slide, you can see how there are multiple clouds drawn. And if you just think about a spring day or a fall day, every time a cloud goes across the sun, you can detect the change in the temperature. So water is an atmospheric gas that has a huge impact on the temperature of the planet. If we have lots and lots of cloud, then those clouds will shield the planet, they will radiate out extra heat, and the planet will cool. If you have fewer clouds, then two things can happen. If it's daytime and the sun is beating down on the area, then more sunlight will enter our atmosphere, will hit the earth and be changed into infrared radiation, and the area will warm. If it's nighttime, then what will happen is those clouds will not act as a blanket, those clouds will not trap in the heat, and therefore the ground will radiate out into the atmosphere much more heat than normal. And that atmosphere will lose that heat out into space much faster than normal. So you will get much faster cooling of the planet than normal. So if we're dealing with a winter's evening, and that winter evening is bright and crisp with not a cloud in the sky, there's a very high chance of getting frost, because without that cloud cover, lots of the heat is radiated back into space and the planet cools down, making that frost condition. So remember that water has a huge impact on the temperature of the planet. Being clouds, and those clouds white in color on the top, even if it's a thunder cloud, the top of the cloud is white, really provides an excellent shade cooling down the planet. And the opposite effect, if it's nighttime, they act as a blanket and they seal heat in. So human activity is not increasing the amount of clouds. One thing that we're not doing is we are not adding huge numbers of clouds or removing huge numbers of clouds from the atmosphere. So again, that leads us to the number one culprit for the actual change in the temperature of the planet being carbon dioxide. Right, so that was the greenhouse effect. What we're now going to move on to is what the papers call global warming. Now, scientists started to notice the temperature of the planet increasing, and they started to produce multiple papers on this. Governmental bodies got in on the act, and they generated at the UN the IPCC, the Intergovernmental Panel on Climate Change. And this is a group of multiple nationality scientists that work together to produce data and research papers on temperature change on the planet. Now, there is a lot of controversy over the IPCC. These people work to determine climate change, so their employment depends on them actually having climate change. So we have to first of all question, is the integrity of the scientists there? And really there's only one way to determine that, and that is the results reproducible? If a university in China finds X result, then when the United States universities do it, they should find X results. And I am happy to say that for most of the work produced by the IPCC, when they are redone at different universities around the world, the same results are calculated. So what's the IPCC basically saying about climate change? Not surprisingly, they say that the climate has changed, that the temperature of the planet is warming up. They say that this warming will have raised sea levels, and that sea levels have raised slightly already. And they say that there is a strong correlation between the temperature and the amount of greenhouse gases, particularly carbon dioxide. And that it appears that that extra carbon dioxide is being released from human activities. So the IPCC says that human activities appear to be releasing more greenhouse gases into our atmosphere. And by far the most important seems to be carbon dioxide. So as we do our daily activities, we're increasing the amount of carbon dioxide in the atmosphere, and that carbon dioxide is acting as a greenhouse gas and trapping more heat into our atmosphere, raising the temperature of the planet. So if we were to do research on the amount of heat trapped in the planet, what we'd have to do is go back and look at average temperatures over the planet and plot those. And one thing that we would see is that the temperature of the planet is extremely variable. So when you look at our graph here, it wiggles up and down, up and down, up and down. Global temperatures are not stable. They fluctuate all the time. So there's a large amount of natural variation within the temperature of the planet. Is there a general trend that it becomes warmer and warmer though? According to the IPCC, even though there is large amounts of fluctuation on the planet in terms of temperature, the general trend is that the temperature of the planet is going up. So that's what we have. We have that the temperature does fluctuate. Just because this year is really, really hot doesn't mean that next year is going to necessarily be hotter because of this natural variation. Some years are hot, some years are cool, some years are really hot, some years are really cold. But on average, the temperature of the planet seems to be increasing. At the same time, they're looking at carbon dioxide concentrations, and one thing they can tell is that carbon dioxide concentrations in our atmosphere are increasing. As we're burning coal, as we're burning oil and gasoline at higher and higher amounts, remember the world population has increased, so there's more homes, there's more cars, there's more trucks, there's more power plants, there's more people using computers and electric lights. As we use all of those energy sources, as we burn those fuels, we're generating carbon dioxide. So the amount of carbon dioxide in the atmosphere is also going up. It is variable. Every natural system is variable. But the general trend is that the amount of carbon dioxide is increasing. So when you superimpose the temperature of the planet with the amount of carbon dioxide present in the atmosphere, you get a graph that looks like this. The temperature of the planet tends to be showing a very fluctuating, very variable graph, but with a trend towards warming temperatures. Carbon dioxide is increasing, tending towards higher levels of carbon dioxide. And if we superimpose them like this, we can see that the two graphs tend to mirror one another. As the carbon dioxide level goes up, the temperature goes up. So superficially, we can say that there appears to be some correlation between the amount of carbon dioxide on the planet and the temperature of the planet. So there appears to be correlation between the amount of carbon dioxide on the planet and the temperature of the planet. Now here's the kicker though. The kicker is, does this prove that human released carbon dioxide is increasing the temperature of the planet? And the answer to that question is no. To be able to prove that the carbon dioxide is increasing the temperature of the planet, we would have to do an experiment. And that experiment would have to be on the scale of the planet. What we'd have to do is we'd have to add carbon dioxide, and as we added the carbon dioxide, we'd expect the temperature to warm up. And then we'd have to remove carbon dioxide, and as we took away the carbon dioxide, the temperature of the planet would go down. So by doing this numerous times, we'd be able to prove the correlation between carbon dioxide and temperature. We do not have the ability to do that on a planetary scale. There is no way that we can take the Earth and add a ton of carbon dioxide and watch the temperature warm, suck out a bunch of carbon dioxide and watch the temperature go down. If we had that ability, nobody would be discussing the climate change, because we'd just remove some of the carbon dioxide and see if the temperature went down, and if it did, well, we'd fix the problem. So if you ask a scientist, is there proof that carbon dioxide is warming the planet? The correct answer would be no, there's no proof. However, there does appear to be a correlation between carbon dioxide and temperature. So let me just say that again. The correct answer would be there's no proof that carbon dioxide is increasing the temperature of the planet. There is just a correlation between the amount of carbon dioxide and the temperature. Now I'm hoping you can see that if you were to edit that type of tape, you could make that scientist say anything you wanted. You could make him sound like the carbon dioxide is definitely warming the planet, or you could make him sound like carbon dioxide is not having anything to do with the temperature of the planet. So we know that carbon dioxide tends to have a correlation, but what does that actually mean in terms of our industry and our policy and the future of the planet? Well, we need to remember what the goal of environmental science is. And the goal of environmental science is to produce a sustainable society. So if we look at where the extra greenhouse gases are coming from, we get this graph here. And we see that most of it is coming from burning fossil fuels. And a whole bunch of it comes from deforestation or industrial processes. Remember that fossil fuels are non-renewable. And also remember that we need to maintain a high biodiversity for the stability of the planet. So deforestation is not sustainable. So if we were to remove the fossil fuels by moving towards a more renewable fuel source, automatically we start to decrease the human impact on global warming. So if we just deal with what we've talked about so far in terms of energy, and what we've talked about so far in terms of primary and secondary air pollutants, if we were to actually move towards a sustainable society, we should automatically be fixing the issue of global warming caused by humans. And what if the global warming is not caused by humans? What if it's not anthropogenic warming? What if it's just a natural warming cycle? There are politicians out there who suggest that the warming is nothing to do with our industrial processes. They suggest that the temperature of the planet has always changed, and therefore we're just seeing a natural cycle of the planet warming and cooling. And they're true. The planet has always gone through cycles. We've been through periods where the planet has been extremely cold, where glaciers pushed down through most of North America. And we've been through periods where it was extremely warm, where the Arctic melted completely, and where Antarctica had reptiles living on it because the temperature was so warm. So the planet has gone through periods of warmth and periods of cool, and that is just a natural cycle. Now, there's no way that we can interfere with planetary scale natural cycle warming and cooling, particularly if it deals with the sun getting hotter and cooler. So we need to separate out what is just natural heating and cooling and what is abnormal anthropogenic heating and cooling. And that's where, in this class, we're going to change the name from global warming to rapid climate change. Because the truth is, the planet is always warming and cooling. The planet goes through cycles of warming periods and then goes through cycles of cooling periods. We go into ice ages and come out of ice ages. That's all natural. So it is a natural cycle that the planet should heat and cool. And means as we are going to take a conservation approach, we're just going to allow the planet to go through cycles of heating and cooling. What we have to guard against is anthropogenic caused heating and cooling. So is this period of change anthropogenic or natural? And the way to look at that is compare the speed of climate change at the moment to previous changes. When we've been going into and out of ice ages on the planet, the change has always been an extremely slow process. And when we look at the change in temperature on the planet today, we see that the change is extremely fast compared to previous changes. So the change in temperature is probably not the problem. The problem is the rate of the change in temperature. The fact that climate change is occurring so rapidly. So global warming is not the issue. The globe would naturally warm and cool. The issue is how fast it cools or how fast it warms. Right now we are seeing rapid climate change. We are seeing very quick warming of the planet. And rapid climate change is beyond the ability of most of our major biomes to cope with that change. So here's a quick graph showing areas of the planet that are likely to see warming periods, areas of the planet that are likely to see more rain. Now, what we've got here is we've got some areas that are getting more rain with the hash marks, some areas that are getting less rain with little splattered marks. Some areas are really getting hotter with the deeper colors, some areas are really not changing at all in terms of temperature. So notice that some areas of the world will warm much quicker than other areas. And some areas really don't change at all. So global warming does not in fact mean that the world will get warmer everywhere. Rapid climate change just tells a much more refined story. It says that your climate is going to change, and it's going to change quickly. So for some people, their climate will change and it's going to get a lot hotter. For other people, it won't. It won't get warmer. In fact, winters will be cooler. It's going to get cold winters. It's going to say some of you are going to get drought conditions more often, whereas some of you are going to get rain conditions more often. Now, unfortunately, the difference between just local short-term variations and long-term global climate variations can only be told with time. So just sitting here during our lifetime, we're not going to know whether this is just a short-term effect or really is a long-term global warming effect. So we have to make the assumption, therefore, that if rapid change is occurring, that's going to lead to long-term effects. And if rapid change is occurring, then we need to do all we can to make sure that that's not anthropogenic caused rapid climate change. So what would happen if the amount of CO2 we're releasing is in fact causing rapid climate change, is warming the planet? There are a number of different things that will happen. First one, glaciers will melt. Alright, so as the temperature warms, then we should expect to see ice melting. So this picture was taken by the Russians, and it went around the world very rapidly because this Russian icebreaker was out in the North Pole zone, and it was the first time anybody had ever gone to the actual position of the North Pole and found no ice there. So when this picture was first snapped and then verified by an American naval vessel, people around the world were definitely doing the doomsday dance and saying, oh my gosh, global warming's real, the world's coming to an end, there's no ice at the North Pole. Now since then, as soon as we went into winter, ice reformed and the North Pole now has ice in it. So remember that the Earth has gone through this multiple times before. There's been plenty of times when no ice was at the North Pole. Idea here is that change is happening faster than would normally be seen on the planet. Not that change is occurring, just that it's going very, very quick. So what is the downside of having no ice in these zones? And there are multiple downsides. One downside is, what about the animals that live on that ice? What about the walruses? Where do they pull out if there is no ice to pull out onto and they have to swim their whole life? What about polar bears that hunt on these ice floes? Not right at the North Pole, but closer towards the United States. Polar bears move from ice floe to hunt seals and walrus. And if there's no ice floes, then their hunting grounds are destroyed, and we see a decrease in biodiversity. Not only do we get this decrease in biodiversity, but that melting ice also produces water. Now, if you take a glass of ice and you add water to it, you know that the ice floats up. The ice cubes float on your water, they bob up because they're less dense. So when they melt, they make more dense water, and that water flows into the ocean, goes into the ocean, and increases the amount of water in the ocean. So our sea levels go up. The amount of water in the ocean increases. Not only does the ocean increase because the glaciers are melting and ice is melting, but also as the water heats up, it physically gets bigger. When you take an object and warm it, because heat is molecular motion, the molecules, even though they're vibrating and you can't see this in a solid or in a liquid, those molecules move apart a little bit. As those molecules move apart a little bit, that means that the actual volume of that substance increases. So if you were to just warm the Atlantic Ocean, the physical size of the water in that ocean increases, the molecules move apart, and sea level rises. So both of these effects will cause flooding of coastal areas. So here's a prediction map of flooding if we get a sea level rise of 1.5 meters and 3.5 meters. And these are large amounts of sea level rise. There's no doubt about it. This is a lot of sea level rise. This would be caused by a large amount of global warming. But you can see that large areas of Florida and Louisiana get covered with water. It's even more devastating in Egypt, with their major food producing areas being flooded. Bangladesh would cease to be a functional country, and the part that's coloured in red and purple here is its main food producing areas. The rest of Bangladesh is very mountainous. So what we would see is huge numbers of refugees coming from Bangladesh because they would no longer be able to farm enough food to support their population. And just to the north of Georgia, we've got North Carolina, and the Outer Banks would all be covered with water and be flooded as well. So we've got some US examples and some examples from around the world, and you might say, well, I don't live anywhere near the seaside, so why do I care? I know sometimes when I talk to my dad is totally like, can't wait for global warming. At the moment it takes us 2 hours to get to the coast. Let's get that sea level risen, and hopefully it'll only be an hour away. So he's taking a very anthropogenic viewpoint there of just wanting to be closer to the seaside. But if you live away from the coast, this will still have an impact on you. And that impact will come in the version of environmental refugees. The people that have homes here have to move, and they're going to be moving into your area. All these people will probably have insurance, and if they have federal flood insurance, then it's the federal government that is paying out for their flooded homes, and that will just increase the cost of your flood insurance. If they have private insurance, then private insurance companies are going to have to pay large claims, and again they'll pass that right on to you, and your insurance for your home and your car will increase. So this is going to cost you money. It's going to hit you in the pocketbook. Not only will it hit you in the pocketbook, those people moving into your area will also be competing for you, with you for jobs. So again, just because you don't live in that area, because of our system, we will be providing support for these people, and your tax money will be paying for it. We will be paying for it in terms of insurance, and you will be paying for it in terms of competition for resources, jobs, once those people move into your area. So you can't just say, I don't live on the coast, it has no impact on me. It always has an impact on everybody. What else will the warmer temperatures cause? Well, those warmer temperatures also cause changes in the pattern of rainfall and changes in the way the wind blows. Remember that the wind blows because of differential heating of the planet. Some parts are warmer than others, and therefore the low density air rises, high density air sinks, causing the winds to blow. So as you change the temperature of the planet, you change the way the wind blows. And as the wind blows in different directions, the clouds are moved in different directions, so it rains in different places. So we're going to see some areas get hotter and drier, and we should see hotter and drier deserts. And as we already said earlier in the course, the fastest growing biome on the planet is our desert biome. So deserts are expanding. As we have more energy in our atmosphere because of higher temperatures, that can breed more violent storms. So we should see higher amounts of violent weather, more tropical storms, more hurricanes, more cyclones. And the last one is probably the most important one. Those changes in precipitation and temperature will change our plant communities. Remember that the biomes of the world exist in their positions because of two factors: precipitation and temperature. And rapid climate change is changing the temperature of the planet and changing the amount and position of the precipitation that's produced. So we're changing the two things that lead to the biomes being where they are. So biome conditions will change. So one model that's predicted out there says that if you look in the area where we have sugar maple needs cool winters but nice summers to survive. As the temperature on the planet warms up, the temperature range and precipitation range needed for those sugar maples will not stay the same, and therefore the sugar maple's ideal physical conditions will be elsewhere. And the sugar maple range would move into Canada. Now, traditionally, with our ice ages, biomes have gone through this change multiple times in the history of the Earth. Biomes move north, biomes move south as ice ages occur and then abate. The key here is rapid climate change. A biome is based on its food chain. And the base of the food chain, the base of that pyramid of numbers, are the producers. And producers do not have legs to get up and walk about. If the temperature or precipitation changes, unlike deer, unlike elephants, unlike humans, the producers do not have the ability to get up and walk to more favorable conditions. So when we're looking at biome movement, what we're looking at is, do the plants have the ability to move through reproduction to keep up with the rate of climate change? So as the biomes move in, the way that producers move is they produce seeds. Those seeds have to land, produce offspring, germinate, make the little trees. The trees have to grow up, produce more seeds. Those seeds have to be blown in the right direction, land on the ground, germinate, produce babies. So if we're talking about oak trees, that could be 30 years before they're ready to germinate and move up the next generation. And pine trees, we're looking maybe 10 years that they're going to be generating offspring and moving. So in any of these events, producers move very slowly, particularly trees. So as long as climate change occurs slowly, the biome can move with that climate change. If the climate change occurs rapidly, the biome cannot move with that climate change. The climate will no longer fit that producer, and that producer cannot live, cannot reproduce, and will become extinct. So our worry here with rapid climate change is the temperature of the planet changing so rapidly that our producers cannot move with it anymore. A great example of this is coral reefs. Coral reefs, the coral is a little jellyfish type of organism, but inside of it is a producer, zooxanthellae. And the zooxanthellae are a type of alga. And when the water temperatures warm up, a lot of these algae do not survive well. So the coral tends to eject them, and the coral becomes completely white. It's called coral bleaching. Now, if the temperatures change slowly, then the coral can adapt and get new zooxanthellae from different species. So different types of algae move into the coral, and we see the coral change with the temperature change in the water. If we have rapid climate change, the coral do not find the right type of alga. The algae doesn't survive at that correct temperature. The coral bleaches, has no more algae in it, starves and dies. So we need a nice slow rate of change to allow the environment to change with the climate. A fast rate of change will just destroy the biome. So what can you do to help prevent global warming? Nice and easy. A nice little list there. And I'm sure if you just pull that up, you'll be able to read what they are. But basically, you've got to produce less CO2. And to produce less CO2, you have to be more efficient. It is always easier to be more efficient than it is to develop a brand new energy source or a brand new technology. Utilizing the efficiencies that we have to us is much simpler than coming up with a brand new energy source. So as we've seen with your worksheets, the vehicle you drive and how you drive it has a huge impact on the amount of CO2 that you produce. The temperature you set your AC to and how insulated your home is has a huge impact on the amount of CO2 you produce. How efficiently you use your refrigerator and your dishwasher, how efficiently you use your hot water has an impact on the amount of CO2 you use. So if you're just more efficient, then you will decrease the amount of CO2 and you will slow down climate change. And slowing down climate change has other benefits as well. Being more efficient would mean that our fossil fuels last longer, and therefore we are being more sustainable. We have longer to find the correct technologies to be able to switch to a renewable system, and that renewable system is what we need to be fully sustainable. So as a society, what can we do? Well, we can always cut down on coal use, obviously. If you think back to the energy lectures, you should be able to come up with new ways to generate electricity instead of coal. We've got to improve energy efficiency, and you've done a worksheet on light bulbs and on cars, so you should be ready to go on talking about energy efficiency. We've got to shift towards renewable energy sources, getting rid of burning the fossil fuels, and then use those resources to do mass transport as well as individual transport. And a couple that are often forgot is we need to reduce deforestation. Plants absorb carbon dioxide, so by keeping large amounts of plants in an area, you actually remove CO2 from the atmosphere. So we need to maintain the size of our forests so that our forests can absorb CO2, lock it away, and therefore we don't have to worry about so much CO2 in the environment, and the temperature of the planet will be stabilized. Sustainable agriculture. Sustainable agriculture, as you'll see in the last series of lectures, is going to include keeping crops on the ground all the time, and those crops will be absorbing CO2. It's going to be using not as much diesel fuel to plant and harvest our crops, so we're not producing as much CO2 per unit of food. And it's going to be using fertilizers efficiently, because fertilizers can be converted into nitrogen gases, and those nitrogen gases go into the atmosphere and act as a greenhouse gas. And the last one is slow population growth. As the world population continues to expand, everybody wants a home with air conditioning, everybody wants a vehicle, everybody wants a computer, electricity and gasoline demands go up. And as each person uses more energy, they're producing CO2. And they also need somewhere to live, so they need to cut down a section of forest to put their house. They also need food, so we have to do more aggressive agriculture. You can only overcome those effects if we slow down the rate of population growth. We need to be in front of the population growth curve. It is a large population that leads to environmental damage. If we can stabilize our population, then we can get in front of this, and global warming is fixable. So when you do go to the store and you want to buy a new piece of electrical equipment like a refrigerator, please look at the energy guide. Here's an example here of a refrigerator that is using $66 per year to run, whereas the worst efficient refrigerator of that same size and class is using $116. By now you should have done your worksheet on life cycle cost. So please utilize the life cycle cost when making consumer decisions. And life cycle costs will mean that you're using more efficient electrical equipment, and will also tell the manufacturer that they should be producing more efficient electrical equipment, because that is what is bought. I really like this slide. This is the last one for this series over rapid climate change. So we've got a graph, and it says on the one axis seriousness of the nasty event. So there's a low seriousness and a high seriousness. So for high seriousness, if we're attacked by a foreign army, that's pretty serious. If your house burns down, that's pretty serious. If you get a little bit of tooth decay, that's not as serious. And then on the other axis, we've got likelihood of the event, and we'll go from low to high. The chance of the United States being attacked by a foreign army is not that high. It's very serious if it happens, but it's not that high. The chance of your house burning down is also not very high. It's very serious if it happens, but the likelihood of your house burning down is very low. Tooth decay, on the other hand, very high likelihood. If you don't brush your teeth, if you're not flossing, you're probably going to get cavities. You're going to have fillings. So on here, where would rapid climate change, global warming be? Is it really, really serious, or is it not so serious? Is it likely to occur, or is it not so likely to occur? And if you think it's serious, then you would probably want to invest money into solving that solution. If you think that it's not serious, then you probably wouldn't want to spend any money on it. If you think that the likelihood of it occurring is very high, then again you'd want to put research funds towards global warming. If the likelihood of it happening was very low, you probably don't want to waste your money on it, because the chance of it ever happening is extremely small. Now, as we say, the fact that the planet is warming is easily shown. So the fact that the planet is getting warmer is definitely shown. Your task is to try and work out, okay, well, how serious do I think that is? And therefore, how much money do I think our government should spend in fixing this problem? How much money should we spend in generating a solution? Now, that generation of that solution may be to produce usable wind power that makes electricity at a steady rate instead of peaks and troughs, in producing solar energy that could supplement our need for coal. So you've got to think about do I really think this is a serious problem, and B, if so, how much should we be spending of our GDP, our gross domestic product, on actually preventing this from occurring? Sort of an interesting problem. I also like this last piece, the tooth decay one. Tooth decay, extremely likely to happen. It's just going to happen, and yet dentists cannot get people to floss their teeth. It doesn't matter what they do. They can point out to it, hey, this is definitely happening. It's here. Please floss your teeth, and you still don't floss your teeth. I mean, I know the last time you guys flossed your teeth was when your dentist did it for you the last time you went to the dentist. So if we can't get people to floss, even though we know that's going to be something that's going to happen, it's going to lead to decay, what do we do about something that is much more extrinsic, much more abstract, like global warming? Should we be surprised that most people on the planet really don't want to get into the idea of global warming and think about bad things? They want to think about bad things that happen in their mouth, let alone what could be happening on a planet scale.